Hi, I'm from Team BugByte and I'll be taking you through our project EarnGuard, which is the first one for our Guidewire DevTrails hackathon. So the problem statement is about gig economy and their insurance, how their income can be secured. And the persona which you have chosen is quick commerce. So there are three categories: quick commerce, food, and e-commerce. Which we have the one we have chosen is quick commerce, like Zepto, Blinkit, Swiggy, Instamart, stuff like that. So I'll come to the persona profile. So let's say there's a person Ravi who earns 4,500 to 6,000 rupees per week. So the premium he can take is like it will be around 2.5 to 3% of his weekly earnings. So we have different plans of weekly premium, and in different plans there will be different types of coverage will be which will be provided to the rider. Okay, and then there will be like dynamic premium calculation. So the risk score will be there to calculate the premium calculation. Okay. So basically, let's say there's a period of time in November or December where there is high chances of rain in Chennai. So at that time, we already know that there will be high rain and there will be disruption. So that time will increase the amount of premium. Similarly, if we know if there is elections are going on and there will be political rallies and everything. So the roadblocks will be there and everything will be there. So that can also cause disruptions. So keeping all those things in mind, the dynamic premium will be calculated. So we have mentioned the formulas about that and the calculations. And then activation mentioned the platform will be like fully automatic, like there will kind of, let's say, zero interaction. So the rider will basically, he won't have to go and make some claim and his request should be getting approved and all that. It will be getting automatically approved when the trigger is happening in our system. It will automatically generate a request and give him the claim. Okay. Moreover, these are all the triggers which will be, detected to make that. These are all the scenarios which will be detected to make the trigger, and according to these triggers, the claim will be given to the writer. Okay. Moreover, the payout formula which is 75% of the actual claim. Let's say he was earning 75 rupees per hour, but we will be giving him will be 75% of whatever he should earn for that particular time. Let's say his 3 hours of his time was disrupted. So 75 into 3 is the actual amount he would earn, but what we would give him as a compensation is 75% of that amount. So that is 75 into 3 into 0.75. Okay, so that is a calculation which you have taken, which not only gives the rider some amount, but also keeps the company in profit. Okay. Then ML integration, there will be like three different models which will be there. So one will be for premium calculation, other will be for fraud detection, and other will be for predictive analysis. For fraud detection, there will be a rule engine, which will be isolation forest, which I'll come in the architecture diagram. So this is the like platform or justification, like mobile app and everything. So coming to this architecture overview, I'll open this in new tab. So if you see this, there will be an app where there will be three services: policy service, there will be claim service, and user service. So claim service will just go to isolation forest, which will detect for fraud. How it will detect is like it will check for the particular location, it will check for the a crisis happening in that particular time frame, and we will already have the working hours of the rider and everything. So combining all those details, it will check for a fraud detection if there is a fraud detection happening or not. So yeah, all those things will happen, and when the checks are ticked, there will be an auto payment to the rider using Razor Pay and stuff like that using APIs. And moreover, auto payout will be done. The premium will also be auto debited from his account every week. Okay. So yeah, this is all about the architecture. So I'll come to this all the market crash part, which was the uh, you know, if there is a fraud, like how we can get safe from it. So yeah, this is the tech stack, like what all we have used for API. We'll be using Spring Cloud Gateway, Java, Spring Boot, Python, Apache Kafka for scheduling, streaming, and then MongoDB for our primary database, Spring Scheduler. All of these things will be used for the primary backend. For front end, for the worker app, we'll be using Flutter or React Native, and admin dashboard will be also made using React. And then Firebase cloud messaging or WhatsApp notification can be, given to the user side, and SMS notification will also be using Twilio. So Twilio is a service which we'll be using for this. ML and AI, these are all the frameworks which you are planning to use. Facebook Prophet for disruption forecasting. Disruption trigger will be done by deterministic rule engine, like zone level yes or no payout decision. And then isolation forest for fraud detection. Okay, so infrastructure and external APIs, all the lists we have mentioned, like where we are getting the API, where is the dataset source, and all the links we have mentioned properly in our README. Then, yeah, so this is the adversarial defense and anti-spoofing strategy. So, as mentioned in the scenario given by market crash and by the guide wire, a coordinated system of 500 delivery workers in Tier 1 city use GPS spoofing apps or fake locations. So, what we thought about this is, yes, a person can fake his GPS, a person can fake his, location using some apps which are available easily on Telegram and stuff like that. So what they can do is they can fake their GPS, but they cannot fake many things at once. Okay, the attackers cannot simultaneously fake their cell tower triangulation. The cell towers are connected to the cell phone, and they coordinatedly give signals to that particular area. That's how even police tracks criminals and IP geolocation. So the person obviously he cannot use VPN. So IP can be used to track down someone's location, and IP address is always connected to a ISP, and ISPs have their particular location. A person cannot spoof his IP address. If he's spoofing his IP address or using a VPN or proxy servers, that is the first. That's already a first red flag. Okay. Then device signals like Wi-Fi, SSID, GPS data. If let's say also we are using like historical delivery patterns. If a person is not delivering in that particular location, why is he giving a claim of that particular location if he has not never delivered in that location, right? So that will be also be done. And then independent public news. So like we have a Brave Search API. So if an incident happens, let's say there's a like a jam or roadblock or something like that, and he's mentioning a claim regarding that. What if there's no such thing? So will that will already come in news rate. So all those things will be coming from Brave API, and that will be already taken care of. Then claim timing variance, like yeah, if there is a coordinated syndicate like this who are like, let's say the scenarios told like 500 people are doing like this. So if this is a coordinated thing, what they will do is they will try to do it at the same time using the same particular location, using very particular GPS coordinates of that location, right? So that will be a first red flag. So if you see here, like we have mentioned here, so since cell tower triangulation, physical device location independent of GPS, so they can fake their GPS, but they cannot fake all of these things at once. Okay, then IP geolocation, VPN proxy usage is already a red flag. And then Wi-Fi SSID fingerprint, if they are using some kind of Wi-Fi, let's say they're sitting in their home and claiming to be something, so that will already give a red flag. Then GPS jitter analysis is also there, like spoofed GPS will unnaturally, like they're putting perfect coordinates for all of the people, right? Then historical delivery zone match, as I told before. And then the one another which took is behavioral fingerprint and temporary consistency. So claim initiation and limit and latency is like how many claims are filed in that particular time frame. Let's say if there are like 50 people and they are trying to claim, put a claim for that particular location at same time. So 50 plus claims from one zone within 10 minutes. That is a fraud ring detection. Similarly, claims are concentrated in an implausibly tight zone. So the already the persona which we have chosen is quick commerce, right? For quick commerce, there's a limited boundary around the dark store. So there is a dark store and there will be 4 to 5 kilometer of radius. In that only the riders will be there. If the rider is making a claim for some other location which he has never been a part of, which he has never delivered to, and he's just making claim to be, to just get some money, so that will be a red flag. Okay, so that will be checked properly. That will, get escalated to a human review as I showed in the architecture. Similarly, device fingerprint similarity. So if we are making an app, we can also get some info from their phones, right? So if they are using some kind of spoof app from APK, from which they got from Telegram or some source like that, all of them will be using the same app, same spoofing app for GPS. All of them will be using, right? So if we get that particular data from that, if we know about the data from where they're using that particular app, they will have the same fingerprint on across all the devices. So if that particular ID is found, we can detect them as a fraud. Okay, so yeah, that is particular about the detection of fraud engine. And then decision engine, yeah, so there will be green, yellow, and red for this, like when the payout has to be happening. So there will be a scoring for this, like how fraud possibility score FPS from 0 to 1. So if it is from 0 to 0.3, it will be in green range. So automatically it will get approved. So yellow will be on soft hold, where verifying your coverage, you'll be hearing back within 2 hours. So something like that. And if it is in red, so like if our system finds something suspicious about it, what it will do is it will take a human plus AI review. So a human will also be reviewing and AI will also be reviewing it. Okay, so we are also protecting honest workers. So the hard design problem is not catching fraudster, it's not punishing genuine workers. So we are not only like focusing on catching some fraudster, we are also have to focus on not punishing the genuine workers who happen to have weak cell signal. Let's say a person is having weak cell signal, okay, and he is in a flooded area. So we cannot, we don't, we cannot, we won't be in a position to put him in a place of a fraudster. So all of these things have to be taken care of. Then what the syndicate cannot fix? So these are all the things which syndicate cannot fake. Cell tower ID is consistent with claimed physical zone, natural GPS micro drift. So all the GPS will be coordinated to a same particular coordinate. So that will be a spoof. Then official IMD, NDMA government advisories for the claimed crisis. So if there's a crisis, let's say flood is there. So NDMA, IMD, all of these will be giving advisories and everything, right? So it will be in news and everything. So all that can be verified. Then 90-day delivery heat map showing the in what zone they are operating in the previous history. Similarly, platform order activity, like how far they have been working with the platform during the disruption time and during the normal times. And claim timing variance and the independent onboarding paths, like how many people are doing this kind of fraud and everything, so that will be checked properly. So yeah, that's all about our README.md, and I hope you love it. In the phase 2 we'll be giving the demonstration of what we have built so far. Thank you.